Good morning, students. Today we will start our lecture number 9 of power system planning. So, yet we have discussed the modeling of the generation system, conventional generation system, and the conventional generation system integrated with the wind power. So, these two modelings we have already discussed. Now, the third type of modeling, we will discuss the generation system under deregulated environment. What is deregulated environment? The deregulated environment, actually it is considering the modern power system. It describes the modern power system because we all know, so the power market all around the world has gone through the privatization. So due to that privatization, the working structure of the power system is restructured. So it is converting from vertically integrated power system to monopolistic power system. So in this, the generation companies, the generation utilities are converting into generation companies. The transmission utilities are converting into transcos, means transmission companies, and distribution utilities are converting into distribution companies. So due to this change, so now we all know the generation companies are private. It may be private, it may be government, but the private companies will work not only to minimize the cost, but they work for increasing their profit in order to maximize their profit. So this is, we have already discussed. We have already described that what are the objectives of the generation system under deregulated environment. So deregulation means there is no regulation. So now this all will be considered. This all will be taken care by the ISO independent system operator. In our India, the independent system operator is the Power Generation Corporation of India Limited, PGCIL. This is independent system operator in our India. So what is the objective of this type of modeling is that in a deregulated environment, the main objective of generation companies is to maximize their profit over the scheduling time horizon. We can see this thing that generation companies is working in order to maximize their profit. And what is the formula for profit? It is very simple. Revenue minus cost. What is this cost? The total cost. This is the total operating cost of the generation companies. Means whatever the cost incurred on generating the power from their generators, this is that cost. And revenue, whatever the power they are selling. Now here, it is just like the share market, what we have in our India. It is just like the share market. In that, the trading is there. So similarly, in this market, the trading of power is there. The trading of power gives the revenue to the companies. So this revenue minus total cost will give you the profit. So this is the profit for the generation companies. So this profit has to be maximized. And this total operating cost, this TC, this is a total operating cost. This total operating cost is same as we have already discussed in the conventional generating system. Okay. And revenue, how the revenue will be generated, I will tell you the formula for that also. But what are the constraints for this particular problem, for this particular modeling? In this modeling, the power balance constraint, as we have already discussed in the two modelings, here also the power balance constraint, you can see that it is not no more linear in nature. It is not no more equality constraint. It becomes the inequality constraint. Why it is so? Because company, if it is feels so, okay, in every hour the load demand may not be satisfied by the one particular company. This should be satisfied by together all the companies which are participating in that bidding process. So this total demand power, this PD power, will be taken care by the ISO, independent system operator, and the generation companies have not been obliged to satisfy this power demand in every hour. So they can generate the power, they can sell the power based on their profit. If they feel that in this particular hour they are not getting much price, they are not getting much profit, they will not sell power, they will not commit that we will give this much of power. So this is the summation I equals to 1 to n. N is the total number of generators in the companies. We can say total number of generators in one particular company. Okay, this formulation is considering only for one company, one generation company I'm talking about. Means this n type of generators having one generation company. If I will consider the n generation companies, that the formulation will be different. Okay, so here PIT means the power output of the ith generator of that particular company at tth time interval, and this is the unit status of that particular generator of that particular company. So this is the modeling which we are discussing, is considering that only one company is there in the market. Okay, other companies if we will consider, then this constraint will become the equality constraint, that becomes the system constraint. Actually here the load demand is converting from local constraint to the system constraint, because this load demand will be taken care by the system. So spinning reserve constraint is already the system constraint. This is also become the inequality constraint. This is the what which we are seeing, that is a changing from monopolistic environment to the deregulated environment. So this is RIT is a reserve which we have, and in this particular environment we are actually committing the reserve also. We are trading the reserve also, because reserve is the power which has to be sold. This comes under the ancillary services. This comes under ancillary services. Okay, power generation limit is same, that it should be generated within minimum to maximum. And reserve generation limit, okay, what is the reserve generation limit? We know any generator could generate, have some maximum capacity. If it will generate, suppose maximum capacity is 400 megawatt of any particular generator, and it have committed that I will generate power, or I will sell power 300. So 100 is the limit which will remain, that that particular generator can give as a reserve. So this limit will lie between 0 to 100. It means the reserve might be they can give for that particular generator 0 or maximum minus output power. I think it is clear to you. Minimum uptime constraint. This is same as we have already discussed in previous modeling. Minimum downtime constraint, it is also same, which we have already discussed. This must be satisfied, because here what we are considering the thermal generators. The thermal generators must satisfy the minimum uptime and minimum downtime limit, because due to some cost issues, due to some because we know the process under the boiler goes on the gradual change. The temperature under the boiler goes on gradual change. It will not instantly cooled, and it will not instantly hot. So it takes some time. Due to this time, it takes some time to off, and it takes some time to on. So that's why it should be on for minimum time, and it should be down for minimum downtime. Next, the unit ramping constraints. Ramp rate constraints, we have already discussed that every thermal generator should satisfy this ramping constraints. It follows the ramping characteristics. It should not generate the power, maximum power instantly. It takes some time from 0 to maximum. So from minimum to maximum, not 0 to maximum, from minimum to maximum and maximum to minimum. So that is minimum to maximum, up rate constraint, up rate constraint, and maximum to minimum, down rate constraints. So this is all what we have to discuss in this particular lecture. Rest we will discuss in our next lecture. Okay, thank you.